March 17, 1940, somewhere on the frozen roads between Kharkov and Moscow. The lead T-34 prototype lurched through another snowdrift, its diesel engine hammering against the winter cold. Inside the cramped hull, Mikhail Koshkin pressed a handkerchief to his mouth, trying to suppress another coughing fit. The pneumonia he'd contracted days earlier was getting worse with every kilometre, but he refused to stop. His tank, his design, had to reach the Kremlin under its own power. Behind him, a second prototype followed, both machines grinding eastward through conditions that would have immobilized any conventional tank. And pressed against the driver's compartment, hidden from official inspection reports, lay the real secret of these vehicles. Not the diesel engine, though that mattered. Not the Christie suspension, though that helped. The secret was geometry. Angles measured in degrees that would rewrite the mathematics of armour penetration and force German engineers to confront a truth they had dismissed as theoretically inferior. A former candy maker had just solved armoured warfare's most fundamental problem, and he was dying to prove it. The sloped hull plates of Koshkin's design would transform a modest 45 mm of steel into the equivalent of 90 mm of protection. This wasn't engineering magic. It was trigonometry applied with ruthless practicality by a designer who understood that in mass warfare, the tank that could be built by the thousands mattered more than the tank that looked perfect on paper. German engineers in 1941 would measure these same angles with precision instruments at the Kubinka proving grounds, calculate the ballistic advantages with scientific rigor, and reach conclusions that contradicted everything they believed about proper tank design. The arithmetic was simple, even elegant. A shell striking armour perpendicular to its surface had to penetrate only the actual thickness of the praden, a plate, but angle that same armour at 60 degrees from vertical, and suddenly the shell's path through the steel increased dramatically. The effective thickness doubled without adding a single kilogram of weight. Even better, the shallow angle increased the likelihood that shells would simply ricochet off the surface entirely, their kinetic energy deflected harmlessly into the air rather than concentrated on penetration. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. German tank designers in the late 1930s had considered sloped armour. They understood the physics perfectly well. Their engineering schools taught the trigonometric principles. Their metallurgists knew that angled plates provided superior ballistic protection compared to vertical armour of equivalent weight. But they had rejected the approach as impractical, unsuited to their manufacturing methods, and incompatible with their design philosophy that prioritized internal volume and crew comfort. The Soviets, working under different constraints with different priorities, had reached the opposite conclusion. The story begins not in 1940, but 3 years earlier, in the aftermath of conflicts that exposed the inadequacy of Soviet armour. During the Spanish Civil War, Soviet BT and T-26 tanks sent to support Republican forces had performed poorly against German and Italian opposition. The tanks caught fire easily when hit. Their thin armour, rarely exceeding 20 mm, proved vulnerable even to light anti-tank weapons. Infantry armed with improvised incendiary devices could disable them. The lessons were clear and painful. Soviet tank design needed fundamental revision, not incremental improvement. In 1937, the Red Army assigned engineer Mikhail Koshkin to lead a new design team at the Kharkov Comintern locomotive plant, known as KHPZ. His mission was to develop a replacement for the BT fast tank series, vehicles based on American designer J. Walter Christie's innovative suspension, but plagued by inadequate protection. Koshkin, 40 years old and a relatively recent convert to engineering after spending his youth making candy in Moscow factories, approached the problem without the preconceptions that constrained more conventionally trained designers. The initial prototype, designated A-20, incorporated sloped armour as one of several innovations. The design team had studied photographs of the French FCM-36 infantry tank, impressed by its sharply angled hull and turret surfaces. French designers had discovered what physics textbooks confirmed: angling armour increased protection without proportional weight increases. For armor 30 mm thick, angling it 30 degrees from vertical created effective thickness of 35 mm. Angle it 60 degrees, and effective thickness doubled to 60 mm. This wasn't theoretical calculation. It was battlefield mathematics that would determine which crews lived and which died. The A-20 married this sloped armor concept to the Christie suspension system and a new diesel engine being developed at the Kharkov diesel factory. The diesel provided crucial advantages over gasoline: 50% lower fire risk when hit, 30% better fuel efficiency for extended range, the ability to run on various grades of fuel oil in emergencies, crucial for an army operating across vast territories with disrupted supply lines. But military leadership resisted. The A-20's specifications seemed inadequate. Only 20 mm of armor, even sloped. A 45 mm gun, standard but unimpressive. The design appeared to be merely an incremental improvement over existing BT tanks, rather than the revolutionary leap forward that combat experience demanded. Conservative military minds wanted heavier armor, bigger guns, specifications that looked imposing on paper, even if manufacturing reality couldn't support them. Koshkin refused to accept rejection. Working in parallel with the A-20, he developed a second, unauthorized prototype. The A-32 increased frontal armor to 32 mm, mounted a more powerful 76.2 mm L-10 gun, and retained the sloped armor configuration that Koshkin believed was key to battlefield survival. He was risking his career, possibly his life in Stalin's Soviet Union, where technical disagreements with authority could lead to imprisonment or execution. But Koshkin understood something his critics did not. The war approaching would be decided by industrial capacity and practical functionality, not by theoretical perfection. Both prototypes underwent testing at the Kubinka Proving Grounds in 1939. The results surprised military observers. Despite being heavier, the A-32 proved just as mobile as the lighter A-20. The sloped armor worked exactly as predicted, providing protection equivalent to much thicker vertical plates. The powerful 76.2 mm gun could engage enemy armor at ranges exceeding 1,000 meters. Every system reflected design choices optimized for mass production and field reliability rather than showcase specifications. Soviet military leadership, witnessing poor performance of existing tanks during the Winter War against Finland in late 1939 and watching German blitzkrieg successes in Poland, finally acknowledged the need for better armor. Koshkin received approval to develop an even heavier version. The new design increased frontal armor to 45 mm, widened the tracks for better ground pressure distribution, and mounted the newer L-11 76.2 mm gun. Koshkin named it T-34, commemorating the year 1934, when he claimed to have begun formulating his ideas about this universal tank concept. 2 prototype T-34 seconds were completed in January 1940. These were the machines Koshkin would drive through winter conditions to Moscow, desperate to demonstrate their capabilities directly to Kremlin leadership before any bureaucratic resistance could block production. The journey from Kharkov to Moscow covered over 1,800 kilometers, an endurance test that would either validate or destroy Koshkin's design philosophy. The prototypes had to perform flawlessly through conditions that regularly immobilized conventional vehicles. The tanks maintained consistent speed across terrain that would have stopped wheeled vehicles entirely. The sloped hull deflected snow and ice rather than catching it as vertical surfaces would. The diesel engines, designed with generous tolerances that German precision engineering would have considered sloppy, ran reliably in temperatures that would have defeated gasoline power plants. The wide tracks distributed weight effectively, preventing the tanks from bogging down in soft snow, where narrower German tank tracks would have sunk. Koshkin's team reached Moscow on schedule, the tanks operational and ready for demonstration. Kremlin leaders, including Stalin himself, watched as the T-34 prototypes maneuvered through obstacle courses, climbed steep inclines, and demonstrated the effectiveness of their main guns. Stalin reportedly called the T-34 the first swallow of the Soviet armored forces, recognizing that this design represented fundamental advancement rather than incremental improvement. Official approval for mass production followed quickly, but the demonstration requirements weren't complete. The prototype still needed to accumulate sufficient test kilometers to qualify for full production authorization. Rather than transport the tanks by rail back to Kharkov, Koshkin insisted on driving them under their own power, extending the endurance test and further proving reliability. The decision would cost him his life. The return journey through continued winter, conditions worsened Koshkin's pneumonia. By the time the prototypes arrived back at KHPZ, he was seriously ill, his lungs damaged beyond recovery by exposure and exhaustion. Production of the T-34, model 1940, began in September 1940. Mikhail Koshkin died on September 26, 1940, never witnessing the impact his design would have on the coming war. His deputy, Alexander Morozov, was appointed chief designer and would oversee the T-34's evolution through 4 years of brutal combat. The first production tanks featured the L-11 gun and incorporated the sloped armor that Koshkin had fought so hard to preserve. Early production totaled only about 400 units before switching to the improved model 1941 with the superior F-34 gun. The sloped armor configuration that defined the T-34's appearance was radical by 1940 standards. The glacis plate, angled at 60 degrees from vertical, created a distinctive silhouette completely different from the boxy vertical-sided tanks that dominated pre-war design. The turret armor, though less dramatically sloped at 30 degrees, still provided ballistic advantages. Side armor at 40 degrees offered protection against flanking attacks that vertical plates could not match. Every surface was optimized not for internal volume, but for deflecting incoming fire. Soviet metallurgists had developed special alloys for the T-34's armor. The MZ2 steel combined hardness with ductility, able to compress under impact without shattering. This prevented the catastrophic brittle failure that plagued early armor steels when hit by high-velocity projectiles. The combination of proper steel composition with optimal geometric configuration created protection that exceeded the sum of its parts. German engineers examining captured T-34 seconds in 1941 would be forced to acknowledge Soviet metallurgical achievements they had not anticipated. By June 22, 1941, when Germany launched Operation Barbarossa, Soviet forces deployed approximately 967 T-34 tanks concentrated in 5 mechanized corps. This represented only a small fraction of total Soviet tank strength. Most units still operated older T-26 and BT series tanks with vertical armor and gasoline engines. But those 967 T-34 seconds would deliver psychological shocks to German forces that no amount of Soviet numerical superiority in obsolete tanks could achieve. The first encounters occurred within days of the invasion. German tank crews and anti-tank gun teams, fresh from victories in Poland and France, expected to face technically inferior Soviet equipment operated by poorly trained crews. They anticipated quick penetrations, rapid kills, and continuation of the blitzkrieg successes that had characterized previous campaigns. The appearance of T-34 seconds shattered those expectations immediately and completely. Near Grodno on June 23, 1941, Oberleutnant Klaus Weber of the 7th Panzer Division led his Panzer III platoon against a lone Soviet tank approaching across open ground. Weber's gunner engaged at 500 meters, a range where German marksmanship typically guaranteed kills. The 37mm armor-piercing round struck the Soviet tank's turret and ricocheted off harmlessly. The distinctive ringing sound of deflection, rather than the satisfying crack of penetration, told the crew their shot had failed. Weber ordered rapid fire. The gunner, highly trained and experienced, placed 7 more rounds on target. Each one bounced off the sloped armor, leaving impact marks but causing no damage. The Soviet tank continued advancing, apparently unaware it was under sustained fire. At 200 meters, the T-34's 76.2mm gun fired once. The Panzer III to Weber's left exploded. Its 30mm armor penetrated completely. The T-34 fired again, destroying another Panzer III. Weber's driver threw their tank into reverse, retreating at maximum speed, while the gunner continued firing futilely. Only a lucky hit on the Soviet tank's track finally immobilized it, allowing German infantry to approach and destroy it with bundled grenades placed against the engine deck. When Weber examined the knocked-out vehicle, he counted 29 impact marks from German shells. Not one had penetrated. The armor had deflected every round, the shallow angles converting direct hits into glancing blows that carried energy away rather than through the steel. This single engagement demonstrated what thousands of German tank crews would experience over the coming months. Their weapons, adequate against previous Soviet designs, were useless against properly angled armor. Within days, similar reports flooded German command posts across the entire Eastern Front. Panzer crews described Soviet tanks that seemed immune to German weapons. Anti-tank gun. Teams expended entire ammunition loads without achieving kills. The psychological impact was immediate and devastating. German soldiers, told they would face technically inferior enemies, discovered they were outmatched in the most fundamental measure of armored warfare. Their shells bounced off, while Soviet shells penetrated. The numbers told the story with brutal clarity. In the first 3 months of Barbarossa, German forces fired more anti-tank rounds than in all previous campaigns combined. Ammunition expenditure rates exceeded planning estimates by 450%, yet tank kill ratios remained dismally low. Wehrmacht statistical analysis in September 1941 revealed that German tanks required an average of 13 hits to destroy a T-34. T-34 seconds typically destroyed German tanks with 1 to 2 hits. This 13-to-1 ammunition efficiency disadvantage had catastrophic implications for German logistics, already strained by the vast distances of the Russian front. Field reports documented the crisis in stark terms. A single T-34 took more than 30 direct hits from German 37mm and 50mm anti-tank guns during one engagement, survived intact, and drove back to Soviet lines hours later. The inability to penetrate T-34 armor led to the German 37mm Pak-36 being nicknamed the Panzeranklopfgerät, the tank door knocker, because crews simply revealed their positions and wasted ammunition without damaging the enemy. Anti-tank gunners learned to aim at tracks, or the vulnerable turret ring, rather than the heavily sloped hull and turret armor that defeated their rounds. General Heinz Guderian, architect of German Blitzkrieg doctrine, personally investigated these reports near Mtsensk on October 4, 1941. What he witnessed challenged everything he believed about armored warfare. A handful of T-34 seconds from Colonel Mikhail Katukov's 4th Tank Brigade attacked the 4th Panzer Division, destroying dozens of German tanks while suffering minimal losses. Guderian watched through binoculars as German shells bounced off T-34 seconds at point-blank range, while return fire from Soviet guns destroyed Panzer IIs and IVs with single shots at distances exceeding 1,000 meters. In his memoir, Guderian wrote with unusual candor about this engagement. The rapid advance on Tula, which we had planned, had to be abandoned. Our casualties were severe. What made things worse was that the enemy's new tanks were superior to ours in armor and armament. The short-barreled 75mm gun of our Panzer IV was effective only if the T-34 was hit from behind on the gearbox. Neither the 37mm nor the 50mm gun could penetrate the T-34's armor at normal combat ranges. The Russian 76.2mm gun, on the other hand, could penetrate our tanks at distances up to 2,000 meters. Feldwebel Hans Becker of the 11th Panzer Division recorded in his diary on July 3, 1941, his crew's helplessness. "We have been deceived," he wrote. "Our leaders told us the Russians had only obsolete equipment. Today I watched 5 of our tanks destroyed by a single Russian tank we couldn't even damage. My gunner Wilhelm fired 23 rounds, each one bounced off. Wilhelm wept, a hardened soldier who survived France and Greece reduced to tears by his helplessness. The German High Command could no longer ignore the crisis. Hitler himself demanded answers, refusing to believe that Soviet engineering could surpass German technology. A special commission was formed, led by Ferdinand Porsche, designer of what would become the Tiger tank prototype. The commission included engineers from Henschel, MAN, Daimler-Benz, and Krupp. Their mission was to examine captured T-34 seconds and determine how an allegedly backward nation had produced such a superior fighting machine. The first intact T-34 arrived at Kumidor Proving Grounds, 25 kilometers south of Berlin, in early July 1941. The tank had been captured near Grodno on June 24th, one of the first specimens taken during Barbarossa's opening days. German engineers swarmed over it immediately. What they found would shatter their assumptions about German technical superiority and trigger a crisis of confidence that would reshape the entire German tank program. Oberingenieur Wolfgang Fischer from Henschel led the initial armor analysis. For 3 days he measured and calculated, checking his results repeatedly because the numbers seemed impossible. The T-34's frontal armor, sloped at 60 degrees from vertical, provided effective thickness of 90 mm while using only 45 mm of actual steel. German tanks achieved similar protection only with 80 mm of vertical armor, nearly twice the weight. Fischer set down his calipers and stared at the captured tank. In his 20 years designing military vehicles, he had never encountered such elegant simplicity, achieving such devastating effectiveness. His preliminary report to the Commission stated clearly what further analysis would confirm. The entire design philosophy contradicts our approach. We add armor thickness for protection, adding weight that requires larger engines and stronger transmissions. The Soviets achieve superior protection through geometry, not mass. A Panzer IV requires 3,200 kilograms of armor to achieve minimal protection. This T-34 obtains superior protection with 1,900 kilograms. We have been thinking in 2 dimensions while they designed in 3. Dr. Erwin Aders from Daimler-Benz analyzed the armor configuration extensively. His calculations revealed the mathematical beauty of Koshkin's design. By sloping armor at 60 degrees, Soviet designers achieved protection with half the steel weight of German vertical armor. Furthermore, the extreme angle increased ricochet probability dramatically. Many rounds simply skipped off the surface without transferring any energy to the armor. The sloped design eliminated shot traps where vertical and horizontal plates met, points where incoming rounds could be deflected downward into vulnerable areas. The hull design revealed brilliant simplicity that shocked engineers accustomed to complex German construction. The T-34's hull consisted of just 4 main plates, all optimally sloped. Hinrich Kippenkamp from the Army Weapons Department noted the manufacturing implications. This hull could be produced by moderately skilled workers with basic equipment. Our Panzer III hull requires master welders and precise jigs. The Russian design achieves superior performance with inferior manufacturing resources. Professor Porsche personally examined the sloped armor configuration, measuring angles with precision instruments and calculating ballistic performance. His test report acknowledged what German tank designers had refused to accept. The vehicle's protection exceeds anything in our inventory despite using less steel. The sloped surfaces deflect shells that would penetrate our vertical armor. We have fundamentally misunderstood the requirements of armored protection. Our obsession with internal volume and crew comfort has produced tanks that are easier to kill. The armor's material properties added another layer of Soviet innovation. The MZ2 steel alloy combined hardness with ductility in ways German armor steel did not achieve. Under impact, the steel compressed rather than shattering, preventing catastrophic failure. The welds showed rough appearance by German quality standards, but proved stronger than the base material. German engineers had prioritized cosmetic finish over functional strength. Soviet metallurgists had prioritized battlefield performance over appearance. Testing the captured T-34 revealed how effectively the sloped armor worked in practice. German engineers fired 37mm and 50mm rounds at the tank from various ranges and angles. Shots striking the frontal glacis at 60 degrees simply ricocheted away regardless of range. Even rounds that hit perpendicular to the sloped surface had to penetrate equivalent thickness far exceeding their capability. Side armor at 40 degrees deflected most hits. Only shots to the rear engine deck or the turret ring had reasonable penetration probability. The mathematics were undeniable. A German Panzer III with 50 mm of vertical frontal armor weighed approximately 20 tons and provided minimal protection against Soviet anti-tank weapons. The T-34 with 45 mm of sloped armor weighed 26 tons and provided protection equivalent to 90 mm of vertical armor. The Soviet tank achieved superior protection with modest weight increase through geometric configuration rather than brute thickness. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. German engineers measured, calculated, and tested for weeks. Every analysis confirmed the same conclusion. Soviet designers had solved armored protection more effectively than German engineering schools had taught possible. The sloped armor wasn't a minor improvement. It represented fundamental rethinking of how armor should be configured, and the implications extended far beyond a single tank design. The immediate impact on German manufacturers was profound. At Henschel & Son, the entire VK 36.01 heavy tank project was scrapped after engineers realized its vertical armor was obsolete. The company lost 6 months of development work and 12 million Reichsmarks in investment. Ferdinand Porsche's competing design faced similar cancellation. Porsche himself admitted in a private letter that the Russian tank has made 2 years of our work worthless overnight. At Daimler-Benz, the shock was particularly acute. The company had just received contracts for expanded Panzer III production when the T-34 rendered their entire product line obsolete. Chief engineer Fritz Nallinger convened emergency meetings where engineers openly discussed copying Soviet design features, something unthinkable weeks earlier. Internal company correspondence reveals near panic. One memo stated they were at least 2 years behind Soviet tank development, possibly more. Mann's response was more measured but equally dramatic. The company immediately began recruiting engineers from civilian automotive projects, recognizing that incremental improvements to existing designs were insufficient. They established a special team dedicated solely to analyzing captured T-34 seconds and developing countermeasures. This team would eventually design the Panther, but not before experiencing what they called the humiliation of studying superior enemy equipment. The sloped armor revelation triggered broader reassessment of German tank design philosophy. For over a decade, German engineers had prioritized internal volume, crew comfort, and ease of maintenance. Tanks featured vertical armor because it simplified hull construction and maximized interior space. Turrets were large because crews needed room to work effectively. Components were precisely machined because German engineering culture valued perfection. But these priorities produced tanks that were expensive to build, difficult to manufacture in quantity, and increasingly vulnerable to enemy fire. Soviet designers had started from different premises. Tanks would be operated by conscript crews with minimal training. Battlefield survival mattered more than crew comfort. Mass production capability was essential because attrition rates in modern war would be catastrophic. Simple, robust components mattered more than precision manufacturing, and protection should be achieved through smart design rather than brute weight. These priorities led inevitably to sloped armor, simplified construction, and design choices that shocked German engineers by their practicality. The Commission's examination revealed that sloped armor was just one element of a comprehensive design philosophy that German industry had failed to develop. The T-34's diesel engine provided fire resistance and fuel efficiency. The wide tracks reduced ground pressure for better mobility. The simple 4-speed transmission could be operated by minimally trained drivers. The suspension allowed high cross-country speeds. Every system reflected optimization for battlefield functionality rather than specifications that looked impressive on paper. Wolfgang Fischer's personal notes documented his evolving understanding. Initial entries showed confidence that analysis would reveal exploitable weaknesses. Middle entries showed growing respect for Soviet engineering choices. Final entries showed complete philosophical transformation. "We have been wrong about everything," he wrote in December 1941. Wrong about what matters in war. Wrong about how to design for production. Wrong about the relationship between perfection and effectiveness. The T-34 is our teacher, and we are failing students. The captured T-34 at Kumersdorf represented more than enemy equipment brought home for technical examination. It was physical proof that German assumptions about technical superiority, manufacturing excellence, and engineering culture were catastrophically flawed. Every measurement Fischer took, every test conducted, every calculation completed drove home a simple truth. The supposedly backward Soviets had outthought and outdesigned the master race in the most fundamental aspects of armored warfare. And the sloped armor, that simple geometric innovation, symbolized everything German engineers had gotten wrong. They had the mathematical knowledge. They understood the physics. But they had never applied that knowledge because they were constrained by manufacturing methods, design traditions, and assumptions about what tanks should be. Mikhail Koshkin, the former candy maker with his engineering diploma earned late in life, had seen past those constraints and designed armor configuration that worked because it was right, not because it fit existing paradigms. The German response would be years in development. Two competing proposals emerged for Germany's T-34 counter. Daimler-Benz proposed essentially copying the T-34, including rear transmission, diesel engine, and extensive sloped armor. MAN proposed a more conventional German layout, incorporating sloped armor and enhanced firepower. The MAN design was selected, becoming the Panther, but the Panther would reflect persistent German inability to fully embrace Soviet design philosophy. Where the T-34 weighed 26 tons, the Panther weighed 45 tons. This weight increase cascaded through every system. Heavier transmission to handle the power, wider tracks to manage ground pressure, larger engine consuming more fuel, reduced strategic mobility due to transport difficulties. The Panther incorporated sloped armor because German engineers could no longer deny its advantages, but they couldn't bring themselves to accept the compromises in internal volume and manufacturing simplicity that made the T-34 practical for mass production. Intelligence reports in early 1942 revealed the scale of Soviet T-34 production. Factories evacuated from western regions were reaching full production in the Urals. The Chelyabinsk tractor factory, nicknamed Tankograd, was producing 500 T-34 seconds monthly by March 1942. The Stalingrad tractor factory, despite being under aerial bombardment, continued producing tanks that drove directly from assembly lines to battlefields. German bombing couldn't stop production dispersed across multiple facilities. By mid-1942, Soviet factories were building T-34 seconds faster than German forces could destroy them. The sloped armor that Mikhail Koshkin fought so hard to incorporate into his design was proving decisive, not through individual technical superiority, but through its enablement of mass production. The simple four-plate hull could be welded by workers with basic training. The angled surfaces required less precision in manufacturing tolerances. The weight savings from geometric protection rather than brute thickness allowed use of less powerful engines and lighter transmissions. Everything about the design facilitated rapid, high-volume production that German industry could never match. German tank crews facing T-34 seconds, in increasing numbers through 1942, learned bitter lessons about the importance of armor angle. Training materials were hastily revised to address T-34 vulnerabilities. Crews were instructed to target tracks, vision devices, and the turret ring. These tactics acknowledged German inability to penetrate T-34 armor at normal combat ranges. The proud Panzer force was reduced to mobility kills and mission kills rather than outright destruction. Even these modest goals required numerical superiority and tactical advantage. The T-34's sloped armor influenced not just immediate tactical responses, but broader German understanding of tank design requirements. When Panther development reached production in 1943, it incorporated frontal armor sloped at 55 degrees, nearly matching the T-34's 60-degree configuration. The improved protection came at tremendous cost in complexity, weight, and manufacturing difficulty. But German engineers could no longer produce tanks with vertical armor after witnessing how effectively sloped surfaces defeated anti-tank weapons. Every subsequent German tank design incorporated lessons learned from examining captured T-34 seconds. The Tiger II heavy tank featured sloped armor throughout. The E-series paper projects proposed radical sloping of all surfaces. Even the Panzer IV received add-on armor plates, configured at angles to improve protection. The simple geometric innovation that Mikhail Koshkin incorporated in his design became the new standard for armored vehicle protection, not because German engineers liked it, but because battlefield reality forced them to accept it. The T-34's armor configuration would influence tank design worldwide for decades. American engineers studying captured T-34 seconds in 1943 noted the advantages of sloped armor and incorporated similar configurations into the M26 Pershing and post-war designs. British tank designers moved away from vertical armor toward sloped configurations. French post-war tanks adopted radical sloping. The Soviet Union's own post-war designs continued the principle, with the T-54 and T-55 series featuring even more comprehensive armor angling. Modern main battle tanks, including the American M1 Abrams, German Leopard 2, and Russian T-90, all feature extensively sloped armor as fundamental design elements. The principle that Mikhail Koshkin fought to incorporate into his T-34 design became universal standard for armored protection. 8 decades after the first T-34 rolled off production lines, every military in the world builds tanks with armor configured at angles because the mathematics of ballistic protection proved Koshkin right and his critics wrong. The story of one man's geometric innovation would have remained merely a technical footnote if battlefield reality hadn't validated the design so completely. But through 4 years of brutal warfare on the Eastern Front, the T-34's sloped armor proved its worth in millions of shell impacts, thousands of tank duels, and hundreds of major battles. The mathematics that Wolfgang Fischer calculated at Kumisdorf in 1941 played out in combat statistics that told their own undeniable story. By 1943, German forces had developed specific tactical doctrines for engaging T-34 seconds, all of which acknowledged the superiority of Soviet armor configuration. Wehrmacht training manuals instructed crews to avoid frontal engagements when possible, seek flanking positions where side armor could be engaged, and concentrate fire on specific vulnerable points. The turret ring, where horizontal and vertical surfaces met, offered the best penetration opportunity. The driver's vision port, though small, was a weakness. The rear engine deck armor was thinner and less steeply angled. These tactical adjustments represented complete reversal of German armor doctrine from 1939. Then, German tanks engaged enemy armor directly, confident their guns and armor were superior. By 1943, they were instructed to avoid direct engagements with Soviet tanks and seek tactical advantages through positioning and maneuver. The shift from confidence to caution reflected battlefield education purchased with thousands of destroyed panzers and tens of thousands of dead crew members. German ammunition development responded to the T-34 threat with increasing desperation. Tungsten core Panzergranate 40 rounds offered improved penetration against sloped armor, but required strategic materials Germany couldn't spare. Hollow charge rounds showed promise but suffered accuracy problems at range. The solution German industry settled on was simply bigger guns firing heavier rounds at higher velocities. If sloped armor defeated existing weapons, the answer was overwhelming kinetic energy that no angle could deflect. The Panther's 75mm KWK 42 liters 70 gun could penetrate T-34 frontal armor at combat ranges, but only because it fired projectiles with muzzle velocities exceeding 900 meters per second. The Tiger's 88mm K-36 could defeat T-34 armor through brute force, though at tremendous cost in gun weight, ammunition size, and logistical burden. Every German solution to the T-34 problem involved adding complexity, weight, and manufacturing difficulty. None involved copying the elegant simplicity of properly angled armor. Soviet designers, meanwhile, continued evolving the T-34 around Koshkin's original sloped armor concept. The T-3485, introduced in 1944, featured a larger turret accommodating an 85mm gun and three-man crew, but the basic hull with its 60-degree glacis remained unchanged. The armor configuration that had proven effective in 1941 remained effective in 1944 because the geometry was fundamentally correct. Incremental improvements addressed specific weaknesses without abandoning the core design philosophy. The Battle of Kursk in July 1943 provided the ultimate test of Koshkin's armor design against German attempts to overcome it. The Germans assembled nearly 3,000 tanks and assault guns, including hundreds of new Panthers, and dozens of Tigers specifically designed to counter Soviet armor advantages. The Soviets fielded approximately 5,000 tanks, predominantly T-34 seconds of various models. The resulting clash would become the largest tank battle in history. At Prokhorovka on July 12, 1943, Soviet and German armor collided in close-range fighting that negated German advantages in gun range and optical quality. T-34 seconds charged directly into German formations, closing to ranges where even lighter Soviet guns could penetrate Panther side armor. The sloped frontal armor that had protected T-34 seconds at long range continued protecting them in knife-fight engagements, where German doctrine assumed frontal shots would be unavoidable and fatal. German after-action reports from Kursk documented the continuing effectiveness of T-34 armor, despite introduction of improved German weapons. Panthers could defeat T-34 seconds frontally, but required multiple hits due to continuing tendency of rounds to ricochet off the heavily sloped glacis. Tigers dominated when they could engage at low range, but T-34 seconds closing rapidly often survived long enough to reach positions where return fire could penetrate Tiger side armor. The Soviet numerical advantage in tanks, enabled by the T-34's production efficiency, overwhelmed German qualitative advantages. The arithmetic of attrition favored designs that could be built quickly in large numbers and repaired easily in field conditions. The T-34's simple construction and robust components meant damaged tanks could often be recovered and returned to service within days. German Panthers, with their complex suspensions and precisely machined components, frequently required factory-level repairs for damage that Soviet crews fixed with sledgehammers and welding torches. Sloped armor wasn't just about defeating penetration. It was about building tanks that survived hits, remained operational, and could be quickly repaired. Statistical analysis of tank losses from 1943 onward revealed patterns that validated Koshkin's design philosophy completely. T-34 seconds were destroyed in combat, certainly. No tank was invulnerable, but loss rates per engagement were significantly lower than German equivalent vehicles, and catastrophic kills resulting in total crew losses were far less common. The sloped armor that deflected rounds away from the hull meant that even penetrating hits often struck at angles that reduced post-penetration effects. Crews survived to fight again in replacement tanks. German engineers examining destroyed T-34 seconds noted another advantage of the sloped configuration they hadn't anticipated. When armor was finally penetrated, the angled surfaces often channeled the penetrating round and spall fragments upward or to the sides, rather than directly into crew spaces. Vertical armor, when penetrated, directed energy straight into the tank's interior. Sloped armor, even when defeated, provided some protection through deflection of post-penetration effects. Every aspect of the geometric configuration Koshkin had chosen enhanced crew survival. By 1944, the T-34 had become so numerous on the Eastern Front that German soldiers referred to any Soviet tank as a T-34, regardless of actual type. The distinctive sloped silhouette was instantly recognizable, a shape that triggered immediate tactical responses. German crews who spotted that characteristic wedge-shaped profile knew they faced an opponent that couldn't be casually engaged, that required tactical advantage and often numerical superiority to defeat safely. The psychological impact of the design's visual appearance reinforced its technical advantages. Production statistics told their own story about the success of Koshkin's approach to tank design. From 1940 through 1945, Soviet factories produced approximately 57,000 T-34 seconds of all variants. This exceeded total German production of all tank types combined. More remarkably, T-34 production costs decreased while output increased. In 1941, a T-34 cost approximately 270,000 rubles. By 1943, cost had dropped to 135,000 rubles. The simple sloped hull that could be welded quickly by semi-skilled workers was central to this production efficiency. The contrast with German experience was stark. Panther production required extensive specialized tooling, highly skilled welders, and precision machining for complex components. Production costs increased as wartime conditions degraded manufacturing capabilities. By late 1944, Panthers emerging from factories suffered quality control problems that would have been unthinkable in 1942. Slave labor introduced sabotage. Strategic bombing disrupted supply chains. The complexity that German engineers had chosen over Soviet simplicity became fatal vulnerability. German use of captured T-34 seconds in combat operations provided final proof of the design's superiority from the German perspective. Wehrmacht units desperately short of operational tanks eagerly employed any captured Soviet vehicles they could obtain. Unlike captured French or British tanks which required extensive modification, T-34 seconds entered German service without changes. They worked correctly as designed. German mechanics found them easier to maintain than Panthers. German crews praised their reliability. The enemy's tank performed better than Germany's own designs. The 10th SS Panzer Division captured 12 M4A3 Shermans at Herrlichheim in January 1945 during Operation Nordwind. But when given choice between American Shermans and Soviet T-34 seconds, German units consistently preferred the T-34. The sloped armor provided better protection. The diesel engine was more reliable. The simple construction meant field repairs were possible. A design created by a former candy maker in Kharkov proved more practical than products of America's automotive giants or Germany's precision manufacturers. Mikhail Koshkin died in September 1940, knowing his design had been approved for production, but never witnessing its impact on the war. He was posthumously awarded the Stalin Prize in 1942, recognition that came too late for a man who had sacrificed his health and ultimately his life to prove his ideas were correct. But his legacy extended far beyond Soviet honors or recognition. Koshkin had fundamentally changed how engineers thought about armored protection, not through academic papers or theoretical work, but through a design so obviously effective that it could not be ignored. The pencil that stopped moving in Wolfgang Fischer's hand that July morning in 1941 had traced measurements that disproved decades of German engineering assumptions. Every angle Fischer measured, every calculation he completed, every test he conducted at Kummersdorf proved that a man with unconventional background and unconventional ideas had solved problems. German experts claimed required vertical armor and complex construction. The T-34 wasn't just a better tank, it was proof that German engineering culture had asked the wrong questions and optimized for the wrong priorities. Fischer's final entry in his personal notes, written in December 1941, captured the philosophical transformation forced upon German engineers by Koshkin's design. The T-34 taught us that elegance in engineering is not complexity but simplicity, not perfection but adequacy, not individual brilliance but systematic competence. We who thought ourselves masters were revealed as apprentices. The T-34 was not just a better tank, it was better thinking about tanks, and that made all the difference. The influence of Koshkin's sloped armor, extended beyond immediate World War II applications into post-war tank development worldwide. When American engineers examined captured T-34 seconds in 1943, they immediately recognized the advantages of the armor configuration. The M26 Pershing, rushed into production in 1945, featured sloped frontal armor inspired by Soviet design. Post-war American tanks incorporated increasingly radical armor angles as designers accepted that Koshkin had been right about geometric protection. British tank design, traditionally conservative and resistant to radical innovation, underwent similar transformation. The Centurion, developed late in World War II and produced for decades afterward, featured comprehensively sloped armor throughout. British engineers who had designed the Churchill with its vertical slab sides moved to configurations that would have been unthinkable in 1939. The lessons taught by the T-34 were too obvious to ignore regardless of national pride or institutional resistance. French post-war tank development embraced sloped armor even more enthusiastically. The AMX-30, which entered service in the 1960s, featured radical armor angles and deliberate weight reduction, principles drawn directly from the T-34's design philosophy. French engineers explicitly cited the Soviet tank as inspiration for their approach to armored vehicle design. The legacy of a Soviet designer extended into NATO militaries that would spend decades preparing to fight Soviet successors to the T-34. The Soviet Union's own post-war designs evolved directly from Koshkin's work. The T-44, developed in 1944 but produced after the war, retained the T-34's basic sloped hull while improving internal layout. The T-54, which entered production in 1947, featured even more comprehensive armor sloping and became one of history's most successful tank designs, with over 90,000 produced. Every Soviet tank, through the T-90 of the 21st century, traces design lineage back to principles Koshkin established with the T-34. Modern main battle tanks from every nation demonstrate Koshkin's influence. The American M1 Abrams features composite armor packages configured at optimal angles for ballistic protection. The German Leopard 2 incorporates sloped frontal armor as fundamental design element. The British Challenger 2 eschews vertical surfaces in favor of angled protection. The Israeli Merkava, designed from scratch with no historical legacy to preserve, features radical armor sloping throughout. 8 decades after Koshkin drove his prototypes to Moscow, every military acknowledges that properly angled armor is essential. The story of the T-34's sloped armor ultimately transcends technical innovation to become a study in how engineering philosophy determines success or failure. German engineers in the 1930s possessed all the theoretical knowledge necessary to design vehicles with angled armor. Their mathematics was sound, their understanding of ballistics was comprehensive, their manufacturing capabilities exceeded Soviet industry in precision and quality. Yet they never applied that knowledge to produce the design that battlefield conditions required. Mikhail Koshkin, with limited formal engineering education and unconventional career path, saw past the constraints that limited conventionally trained designers. He didn't ask what tanks should be according to established doctrine or traditional design practice. He asked what tanks needed to be to survive on future battlefields. His answer was geometry over thickness, simplicity over complexity, and mass production capability over individual perfection. Every choice reflected clear understanding of the coming war's actual requirements, rather than comfortable assumptions about what warfare should be. The collision between German expectations and Soviet reality began that morning when Klaus Weber's shells bounced harmlessly off a single T-34. It continued through 4 years of warfare where German tactical excellence and crew training repeatedly proved insufficient against Soviet industrial capacity and practical design. It concluded in the ruins of Berlin, where thousands of T-34 seconds rolled through streets lined with destroyed Panthers and Tigers, the survivors of fighting that validated everything Koshkin had believed about proper tank design. Wolfgang Fischer survived the war and spent his remaining years reflecting on lessons learned from examining the T-34. His son, also an engineer, preserved his father's notebooks from the Kumisdorf testing program. Those notebooks document not just technical analysis, but intellectual journey from dismissive superiority through grudging respect to genuine admiration. Fischer came to understand that the T-34 represented not Soviet luck or accident, but systematic thinking about problems German engineering culture had failed to properly analyze. The final notebook entry, dated May 8, 1945, provides Fischer's ultimate judgment on the vehicle that had shattered his professional certainty 4 years earlier. The T-34 succeeded not through individual excellence, but through systemic optimization. Every component was adequate for its purpose. No more, no less. The design was optimized for production by available workers, maintenance by available skills, operation by available crews, and combat in available conditions. German tanks were optimized for theoretical excellence that reality never provided. The T-34 won because it was designed for the war that was actually fought, not the war we imagined. Today, T-34 seconds stand in museums worldwide, monuments to industrial warfare's largest armoured conflict. Their sloped armour remains distinctive even after decades of preservation, the angles still visible that once deflected thousands of German shells. Visitors who run their hands along that 60-degree glacis are touching the physical embodiment of a design philosophy that proved correct when tested against the harshest judge of engineering decisions: battlefield reality. The technical specifications remain impressive, even by modern standards. 45 millimeters of armor at 60 degrees, providing 90 millimeters of effective thickness. Simple 4-plate hull construction, enabling rapid mass production. Weight optimization through geometric protection, rather than brute thickness. Every number on the specification sheet reflects choices made by a designer who understood that perfect was the enemy of good enough, and that good enough in quantity beat perfect in scarcity. But the specifications tell only part of the story. The T-34's true significance lies in what it proved about engineering philosophy and design priorities. Mikhail Koshkin demonstrated that unconventional thinking, when based on clear understanding of actual requirements, could surpass conventional excellence that optimized for the wrong goals. He showed that simplicity, when properly applied, was more effective than complexity that served tradition rather than function. He proved that geometry could achieve what brute force could not, and that smart design mattered more than precision manufacturing. The German engineers who tested captured T-34 seconds at Kumisdorf learned these lessons through measurement and calculation, through testing and analysis. Their professional integrity in acknowledging Soviet achievement, despite personal and ideological resistance, provides history's verdict on one of warfare's most influential weapons. They knew, even in 1941 when German armies were still advancing and victory seemed assured, that the T-34 represented fundamental challenge to everything they had believed about tank design and armoured warfare. The pencil, trembling in Wolfgang Fischer's hand that July morning, was not from excitement of discovery, but from recognition of defeat. Not just military defeat, though that was coming. Intellectual defeat, philosophical defeat. The defeat of assumptions and traditions and comfortable certainties about German technical superiority. Every measurement he took, every angle he calculated, every test he conducted proved that the supposedly inferior Soviets had outthought and outdesigned the master race in the most fundamental aspects of armoured vehicle engineering, and at the centre of that defeat was the simple geometric innovation of sloped armour, the stupid angle trick that made shells ricochet away instead of punching through. 45 millimeters of steel configured correctly outperformed 80 millimeters configured traditionally. It wasn't magic. It was trigonometry applied with ruthless practicality by a former candy maker who understood the mathematics of survival better than engineering professors understood the mathematics of perfection. The young workers who welded those angled plates in factories across the Soviet Union probably never thought about the ballistic advantages they were creating. They simply followed the plans, making thousands of hulls with that distinctive wedge shape that became the T-34's visual signature. But every hull they completed embodied principles that would influence tank design for the rest of the 20th century and beyond. The angle they welded, according to specifications drawn up in Kharkov in 1939, was the right angle, validated by millions of shell impacts across thousands of kilometers of Eastern Front. German soldiers who faced T-34 seconds learned to recognize that sloped silhouette instantly, the shape that meant danger and often death. The wedge-shaped profile rising above a ridgeline triggered immediate tactical responses, flanking maneuvers if possible, retreat if necessary, direct engagement only with numerical superiority and tactical advantage. The shape itself became psychological weapon, proof that Soviet industry could produce designs German weapons couldn't reliably defeat. Soviet tank crews who operated T-34 seconds knew their armor's protection came from the angles as much as the thickness. They learned to position their vehicles hull down when possible, presenting the sharply sloped glacis to enemy fire while minimizing exposure of the less protected side armor. They understood, perhaps better than engineers who designed the tank, that the geometry saved their lives. The shells that bounced away instead of penetrating were the difference between returning to repair depots and burning to death in their vehicles. The mathematics of angled armor weren't secret or complex. Any engineering student could calculate the effective thickness increase from sloping armor at specific angles. The physics of ricochet were well understood, published in ballistics texts and taught in military academies. What Koshkin brought wasn't new knowledge, but willingness to prioritize geometric protection over internal volume and manufacturing convenience. He asked the uncomfortable question that German designers had avoided. If angled armor is more effective, why are we building tanks with vertical armor? The answer German engineers would have given in 1939 involved manufacturing, complexity, crew ergonomics, internal space utilization, and established design practice, all technically valid concerns, all ultimately irrelevant to the question of whether crews survived combat. Koshkin ignored the concerns that made designers comfortable and focused on the problem that mattered, making tanks that protected their crews from enemy fire. The angle he chose was the angle that worked, regardless of whether it made internal layout awkward or required unconventional manufacturing techniques. That ruthless focus on battlefield effectiveness over design convenience characterized everything about the T-34. The cramped interior that German engineers criticized as inadequate was exactly adequate for crews who needed to fight, not take comfort breaks. The rough welding that failed German quality inspections was stronger than necessary, which meant it was strong enough. The simple 4-speed transmission that lacked German sophistication could be operated by conscript drivers, with minimal training, which was precisely what Soviet armies required. Every choice reflected understanding that good enough for purpose beat perfect for specifications. The war in Europe ended in May 1945, with Soviet T-34 seconds driving through Berlin's streets, past the ruins of the Reich that had believed its technical superiority was unquestionable. The sloped armor that had protected those tanks through 4 years of fighting took them to final victory, its effectiveness proven by the survival of thousands of vehicles and tens of thousands of crew members who would have died in lesser machines. Mikhail Koshkin never lived to see that moment, but his design delivered the vindication he had sought when he drove those prototypes to Moscow in March 1940. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.